So we are starting section 3.7, solving absolute value equations. So for our warm-up, I am having us solve just regular absolute value, or we're working with inequalities, but we're going to start with an equation. So remember that with absolute value, your first step is to get the absolute value alone. Then your second step is to make the two cases. And then your third step is to solve for x, or the variable, whatever it is. So if we follow these steps, we should be okay. So what it means to have the absolute value by itself is when, let me find a highlighter here. Is when this doesn't have anything else with it, okay? If we just glance down to here, this one has that 3 with it, so it doesn't count as being by itself. So the first step is completed. The absolute value is by itself. The second step is to make two cases. So in case 1, it's exactly the same. X plus 5 equals 6. And then in case 2, it's x plus 5 equals negative 6. Okay, then your third step is to solve for x. So on this side, I would just subtract 5, x equals 1. And this side, I actually do the same, but I get negative 11. So in these problems, we actually get 2 answers. And there we go. Same thing on number 2, just to review. The absolute value is by itself. So case 1 looks exactly the same. In case 2, we have to change it to being a negative on this other side. Okay. And then we're going to solve. So I add 1. And then divide by 2. X equals 6. Same thing here. Add 1. And then, oh, this is 10, sorry. And then divide by 2. X equals negative 5. So I still get 2 answers. Okay, so what's going to happen when we do these, same rules, but when we make two cases, we have to make it a negative and also change the sign to a positive. Okay. Actually, I should say you just do the opposite sign and then change it to, you have to flip your inequality symbol. Okay, so the first step is to get the absolute value alone. So in this case, I would subtract 3. And I'm doing this before I make my two cases. Make sure I bring down my inequality symbol. 12 minus 3 is 9. Okay, so case 1 is going to be the same thing. X is less than 9. But case 2, you have to flip your inequality symbol. So it's greater than now. And then I'm going to put a negative 9. And so then what we're going to do is we're going to graph this and we're going to decide if it's an and or an or inequality. So they're both open circles. One is on positive 9 and one is on negative 9. So what I'm going to actually do here, I'm maybe not even going to, just going to do 0. And then I'll do like 3, 6, 9, negative 3, negative 6, negative 9. Just so we have enough room. And then open circle on positive 9. X is less than 9, so it goes this direction. X is greater than 9, so it goes this direction. So the region that is shaded is everything in between them. Okay, and so this is an and. Remember, the and inequalities go together. So when I write my answer, X is less than 9 and X is greater than -9. I just took those answers and I put the and between it. Like that. So then B, I have absolute values by itself, so we're good in that department. So I'm going to make my two cases. Case 1 looks exactly the same. Case 2, you have to flip your inequality symbol and make it a negative. Okay? And then we're going to solve for the variables. So in this case, I -4 from both sides. And this gives me a -2. And in this case, I -4 from both sides. And I get a -6. So in this particular one, I'm only going from -6 to -2. So I probably have room on my graph here. I'm just labeling every other one so I have more space. So closed circle, X is less than or equal to -2. So less than would be going this direction. X is greater than or equal to 6, -6. So I shade everything in between. So this is an and inequality. Like that. Okay. Letter C. Absolute value is by itself already. So I jump right into making my two cases. Case 1 looks exactly the same. I didn't change anything. Case 2, I flip my sign and change it to a negative. And then I need to solve. Add 1 on this side, add 1 on that side. X is less than or equal to 3. Add 1. X is greater than or equal to -1. So I have -1, 0, 1, 2, 3, 4. And I'm going to have a closed circle on +3 and a closed circle on -1. X is less than or equal to 3. X is greater than or equal to 1. So this is shaded in between. So it has to make both of them true in order to fit into that area. Okay. Next one, the first thing I have to do is get the absolute value by itself. So I have to move this 3 first. And then we have -1 plus 3, and that gives me a 2. So case 1 is just X is less than 2. Case 2, X is greater than -2. So then -2, 0, +2. I would have an open circle on both of them. X is less than +2. X is greater than -2. The region in between is shaded. Okay. So, okay, so even with the greater than symbol, we'll have the same expectations, the same rules. the first thing you do is get the absolute value by itself. So in this case, I need to add 20 to both sides. I have the absolute value of x is greater than 7. Case 1 looks exactly the same. Case 2, you flip your inequality symbol and change it to a negative. Okay, so on this one, I'm just going to go 0, and then we'll do 1, 2, 3, 4. Not quite enough. We'll just put 7 here. Okay, x is greater than 7, and x is less than negative 7. So you can see that these go opposite directions. So this is an or inequality. X is greater than 7 or x is less than negative 7. It cannot be both. Okay, letter F. The first thing that I do is get the absolute value by itself. So I move the 5 first. (11 minus 5 is 6. Case 1 is x minus 8 is greater than or equal to positive 6. Case 2, x minus 8 is less than or equal to negative 6. And your first step is to add the 8. X is greater than or equal to 14. Add the 8. X is less than or equal to 2. So we have 2 and 14. So 2, 4, 6, 8, 10, 12, 14. X is greater than or equal to 14. And x is less than or equal to 2. Okay, so this is an or inequality. Letter G, have to get absolute value by itself, so I'm going to move the 10 first. Absolute value is greater than or equal to 2. Your first case is x is greater than or equal to 2. Your second case, x is less than or equal to negative 2. So negative 3, negative 2, negative 1, 0, 1, 2, 3. Close circle on both of them. X is greater than or equal to 2. So it would go this way. X is less than or equal to negative 2. It goes this way. So they go opposite directions. That means that it's an or inequality. Next one here. First step is always to get absolute value by itself. So I have to add the 2 first. Then I have x plus 1/2 is greater than or equal to 4. Case 1 looks exactly like that. Case 2 is x plus 1/2 is less than or equal to negative 4. They do give you fractions. They usually tend to be fairly simple ones that you guys can do in your head. So in this case, I need to subtract 1/2. So this is x is greater than or equal to 3 and 1/2. And then this one, minus 1/2, x is less than or equal to negative 4 and 1/2. So it's greater than 3.5, but less than 4.5. I am just going to put this on there like this. We'll throw 0 in the middle. And then close circle on both of them. X is greater than 3.5. X is less than negative 4.5. Okay, so even if you have fractions, the big thing is just to knowing what kind of circles and what way the arrows are going to go. And if it's an or an and. Okay, so last few types of examples here. First off, we have an application problem. So it says some fire extinguishers contain pressurized water. The water pressure should be 162.5 psi, but it is acceptable for the pressure to differ from this value by at most 12.5. Okay, so we want it to be 162 psi, but we can differ by at most 12.5. Write and solve an absolute value inequality, find the range of acceptable pressures. So one thing that I like to do with this, and I did it before when we were working with absolute value, is I do it in words first. And so, for example, I'm going to say the acceptable pressure. Yeah, that's what they call them. Cannot be any more than 12.5. So it can't differ. We'll say differ here. That difference has to be less than or equal to 12.5. Okay. And so how do we find the acceptable pressure difference? Well, we're going to subtract. Maybe I should write this out. I actually can. Here we go. So we're going to take the acceptable pressure. We're going to take the pressure and we're going to subtract the acceptable pressure. Okay, and then because this is an absolute value, even if this comes out negative, it turns it to positive. So we know that that has to be less than or equal to 12.5. Okay, and what we can do, we can kind of create this like standard formula. So you can take like the desired number, that's what I usually call this. Desired number minus, oh, sorry, I should rephrase this. You would take X minus the desired number. So in this case, we want the PSI to be 162.5. And then you have to have your inequality symbol here. And then this is where your other number would go, your 12. So it's kind of like a basic equation. Okay. Sorry if you can see that. Okay. So we have this number. We can make our two cases. And I know that with this particular problem, I'm sure you guys could give me the answers before you would do any sort of setup of the equation, which is good because that means that you could tell if you set up the equation correctly. I'm going to flip the sign over and then I'm going to change that to a negative 12.5. So you solve this just like normal. And what putting this negative on here, it actually subtracts it from that number that we have there. So this one, I'm going to add 12.5. So that gives me 175, I believe. And then this one, if I take away, oh yeah, there we go. And if I take away, it gives me 150. So that means that the acceptable measure for the PSI is anywhere from, I know it doesn't state a graph, but sometimes this is kind of nice to do, 150 to 175. Anything in between there is acceptable. So the thing is with these absolute value problems is that it can be used for a programming tool. So it can program, maybe like there's an automatic computer system that checks the water pressure of things. You can program what's acceptable in there, and then it can check and see if the number falls within the program. And so it's really neat because the computer just puts that X value in. And then since the equation is created, it can just calculate it automatically. Okay. The last type of problem are special cases, because of course we're going to have special situations. And so when that happens, this is when you're going to notice it. So when I move this over, I get a negative over here. Okay, so anytime we have a negative opposite the absolute value, that's when you know it's going to be a special case. So in this situation, I want you guys to think about this, that the absolute value is always positive, right? So when is a positive number going to be bigger than a negative number? All the time, right? So if this is always going to be true, and so this is all real numbers. Because it's always going to be bigger than whatever. I'm going to show you what this would look like if you continue the problem and you set up the two equations. You would get to the flipping of the symbol, you'd flip it, and then you would have a positive 5 here. And I would add 6. And then when I graph this, you would have, let's do this. 1, 2, 3, 4, 5. And it says x is greater than 1, and x is smaller than 11. Well, 1 goes up and 1 goes down. That means it includes everything. They cross each other, and 1 keeps going down and 1 keeps going up. And so that means that it would be all of them, okay, in this particular case. Okay, so the cool thing is that you don't have to deal with graphing the special cases. Okay, so can the absolute value be less than a -1? No, it can never be less than a -1. So this is just a no solution. And the reason that it can't be less than a negative is because this is always going to be positive. So a positive number is never going to be less than a negative number. So anytime you have a negative, so I add 9 to both sides, absolute value is greater than or equal to -2. Can the absolute value be greater than a -2? Yes, this is all real numbers. And then this one, don't forget that this is division here. This is being multiplied. And then here, this is a -8, so it turns into a -2. Can this absolute value be less than a -2? And it cannot, so it's a no solution. So basically your like what should tip you off to if it's going to be a special case is if when you are going to make your second case and it's already negative. And that was our tip off before too. And so just pay attention to that part of it.